There we go. OK. So the reason why we're taking a break from our usual web development, React, etc. content is because you guys might be starting your project soon. The skeleton is released. There's nothing stopping you guys from continuing to work, although there are a few things related to auth in the skeleton that we haven't covered yet. We'll cover that on Monday. But just in case you guys are starting to code, we want to give you a brief rundown on how to use Git when you're collaborating with your team on your project, because this is going to be very important. I'm going to speed through this stuff just a little bit. We're not going to go through many examples, but the slides are here. We also wrote really nice speaker notes in the slides so that later on, when you're working on your projects, you can go through the slides and just use them as a reference for how to do things as you're collaborating with your team. Because Git can get kind of messy sometimes, so we want to show you all the best practices for when you're doing Git. So what we're going to go over today is we'll re-go over some of the stuff we talked about at the very beginning of the class about how to make commits and how to branch. And then we'll talk more about merging and merge conflicts, which you will probably encounter a lot as you're working. And then finally, we'll dive more into the details of how remote Git works. So let's recall how we make commits in Git. So as we recall, a commit is basically just like a set of code changes that we package up and put a label on. That's all probably relating to some kind of category, some kind of big fix to our code. And we can think about Git as representing this whole history of commits that represents sort of like our version history. And then we have this thing called the head pointer that basically represents where our current working directory, that is like our VS Code window, is representing. So if our head pointer is at the topmost commit, that means that whatever we're looking at in our VS Code is the most recent commit, this styling comments block with CSS, the most recent version. So how do we add a new commit? Let's say we want to add a commit to add the post comments functionality. Then we're going to make all of our code changes in our various files. And then if we're thinking about commitment, we're going to git add, and then the file path for the files and the changes we want to add to our staging area. We do git add with our files. Those changes get added to the staging area. And then add whatever other files we want to add. And then once we're ready to commit, we'll do git commit with a certain commit message. Those get boxed up and added to our commit history. So that was a brief recap of how commits work. Yeah? Oh. Gosh dang it. All right, whatever. I guess I can't walk around. That's sad. All right. I will make sure that on Zoom, I'll just go like that. OK. So we just committed, and then now recall that we also were talking about git commits as this object graph representation where each commit is represented by a circle, also known as like representing a version of our code. And each commit has an ID, which is some big long string of characters, and then a message, which is what the commit is about. So now we're going to briefly review branching that we talked about on Monday. So the basic scenario that we were talking about with why we need branching is, let's say Tony is working on implementing a new feature for his app, and then Andrew says, oh, can you help me fix this bug on the original homepage? And he's like, oh, OK. Then he has to move and start working on that. And then I come along, and I'm like, Tony, we need this feature tomorrow, and you have to do it right now. And then he has to change what he's working on. So he needs to work on all of these different things at once. And so if we didn't have branching, let's say task A, B, and C are the things he has to do. He's making his code changes, making his commits for task A. Then Andrew comes along. He has to make some more commits for this task, and then more and more. And then I come along, and he has to start working on this. And then he keeps adding commits, working on all these different tasks. And it's kind of a little bit of a mess. But then Here's the problem. I come along and I'm like, hey, there's this bug on WebLab Tinder on task C. Where'd it come from? And he has to look through his commit history to figure out when in the versions this bug got introduced. The only problem is, in real life, these tasks are not color-coded. All of the commits look exactly the same. And so he's looking, and he's looking, and he's really sad. So what we need is a way to isolate working on one task versus another. But then once you finish a task and have a version of the code that you like, being able to merge those things back together. So that's why we need branching and merging. So now I'm going to show you an example of a merge. And there's a couple things that can happen when you merge. One is that you merge really smoothly, and it works great. So I'll show you a quick example. Let's say this is my Git demo folder, and I have this thing that says Abby is wearing a party hat, and I'm going to create a new branch. I'll do git checkout -b. You'll be using this command a lot in your projects. New hat or something. And so now I'm on the branch new hat, and you can see that because it says it here. So now I'm going to make some changes. And save them. Git status to see, yep, I modified this. I'll do git add -a. That adds everything, all of the changes I've made. And git commit -m birthday, whatever I want to call it. And now I'm done making my changes in my new hat branch. And I want to merge these changes into my main branch. So I'm going to do checkout back to main. And notice that now that my head pointer is at main, I no longer see the changes that I had made in my branch. But now I'm going to do git merge, and then what did I call this branch? New hat. Yay, that's amazing. It just merged the branches that I made in new hat, the commits, into my main branch. Now I see the change here, and it says it merged successfully. Great. This is a smooth merge. But what happens when the merge isn't quite so smooth? I'm going to do git checkout a new branch. Let's call it bucket hat. And then on my new branch, I'm going to make some changes that actually conflict with the changes that I have in main. So I'm going to say Abby's wearing a bucket hat instead. Like this. So now I'm going to check out back to main and try and, oh, wait, sorry. I need to check out back to bucket hat and make sure I have committed something. OK, so git status, git add my change, git commit. OK, so now I've committed this change on bucket hat, and we can see it. And then I'm going to go back to main and try and merge the changes from bucket hat into main. You'll notice that main still says Abby is wearing a party hat. So I'm going to git merge bucket hat. I'm going to merge the changes from bucket hat into main. And, oh, why did that work? That was not supposed to work. I think I accidentally edited the thing on main. OK, well, either way, for the sake of time, I'm not going to do another example for the merge conflict. But basically what happens is if I have something conflicting when I merge it in, then I'm going to get this error message that says, oh no, merge conflict. Fix the changes and then commit the result. And so I need to go into my editor, manually choose what I want to change and what I want to keep, whether it's the version from main branch or the version from my new branch, and then close out the editor and then merge those things together manually. So that's what happens when there is a merge conflict. OK. Now I'm going to go into talking a little bit more about how we use remote, because this is going to be very important for your projects. Earlier, we talked about how we have a local copy of the code that I'm working on, and we have a copy of the code that's on the remote server, in this case, GitHub. This is where our code is hosted. And if Tony wants to work with me on this code, he's going to have to use git clone. So he clones, and now he has a local copy of the code of the whole repo on his computer. Now Tony's going to make his changes, git add, git commit, etc., so that he's editing the code. Then he uses git push to push the commit that he made here onto remote. And then if I want to see what kinds of changes he made, I'm going to do git pull, and I will take any new commits that are on remote that I don't have and bring them over to my side of things. So the basic workflow, if you're just doing a very simple remote workflow, working on one singular branch, is anytime you start working, pull. Always, 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 always pull. And then you're going to work on stuff, you're going to add, you're going to make your commits, and then you need to pull again to make sure that nothing changed on the remote server in the meantime while you were working. And then once you've successfully merged any changes in, then you can push everything back to the remote server, and now everything will be up to date and clean. So that's one way, the most simple way to work with remote. But the more sophisticated way to work with remote, and this is how I would recommend doing for your projects, and how you'll definitely be doing in any industry setting, is using branches. So let's say that Tony is working here, and his copy of the code of main is up to date with remote, and he's going to make a local branch. He's going to call it weblab.mit, and he's making a branch, but it only exists on his local side. It doesn't exist on remote yet. And so he makes a commit. And then he's going to do git push. He'll try that. Oh, shoot, he got cock-blocked. What happened? It says the current branch has no upstream branch. To push the current branch and set the remote as upstream, use git push, set upstream, origin, new branch. OK, what the heck does that mean? What this means is this concept of upstream basically means that every branch, when you git clone, basically has this little link that Git keeps track of that says, oh, this branch that I'm working on local corresponds to this branch on remote. And there's this link between the two so that when you do git push, Git knows, oh, I'm going to move this to this particular part of remote. But since Tony just created this new branch, weblab.mit, it doesn't have one of these little like links to it, to something on remote. So what he's going to do is he'll do git push set upstream origin, which just means remote, and then whatever he wants to call his new branch on remote. So let's say he wants to call it Tinder. It can be the same name, it can be different, doesn't matter. But now that he called git push with this set upstream flag, now Git knows, OK, I'm going to set up a link between this weblab Tinder branch that I have locally and the Tinder branch that I'm now creating on the remote server. So now he's making his commits, he's doing his stuff, more stuff, and then now he can do git push, and since this connection exists, Git will know, OK, I'm going to take these commits and move them to the Tinder branch on remote. And now, once Tony's like, OK, weblab Tinder is ready, we're all set to go, he wants to merge it back into main. So how do we do that? Well, he's going to check out to main to make sure that he is currently looking at the main branch. Because remember, if you want to merge a branch into main, you need to be on main and then merge the other branch in. And so he's going to type in the command git merge weblab Tinder. He fixes any merge conflicts that arise, does whatever he needs to do, and now there's this new merge commit that he has locally that merges merges all of the commits he made with weblab Tinder into the old version of main. Putting them together, great. And now he wants to push this to remote, because remote has to get merged too, GitHub, etc. He's like, I'm so excited to publish weblab Tinder. It's almost done. Now I can be done with this weird project. And so he does git push. And oh no, he got cock-blocked again. What happened? Here it says, updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. You may want to first integrate the remote changes, e.g. git pull, before pushing again. OK, what does this mean? Well, it says the remote contains work that he doesn't have locally. That probably means that there were commits on remote, on GitHub, that he doesn't have in his local copy. So he's like, what just happened? Why did I get cock-blocked? So he does git fetch. And that basically looks at remote, checks what's going on, updates what he has locally to match it. And he realizes, oh, there's a new commit on remote that Abby had made and pushed onto remote main, while he was working on his weblab Tinder that he didn't realize was there. So now he has to take care of taking this commit that was in remote here and somehow merging that into his own diagram. So what he's going to do is he's going to be on his local main, so his computer, and he's going to do git pull. That's going to take the commit that he doesn't have yet locally and merge it into the main branch of his local repo. And then he might need to fix some merge conflicts, do some stuff, whatever. And then once that's successfully merged, now that the bottom of his object graph looks the same as the bottom of the remote object graph, now he's finally ready to make the merge of weblab Tinder public on the GitHub remote server. So he does git push, and it finally works. He's happy. OK, and then also good practice is once you've successfully merged all your changes in, just delete that local branch. So once you merge this in, GitHub will automatically delete this branch on remote for you. But locally, you might still have this weblab Tinder branch, and it's a good practice to just delete it once you're done merging that feature that you were working on that branch into the main branch. OK, this slide I won't go into in super detail. You don't need to read it all right now. But this is going to be good reference for you when you're going through your project, that basically, if you want to add a new feature, one of the best workflows is to create a local branch, create a new local branch, do some work, whatever you need to, and then create a remote branch that corresponds to our local branch, setting up that link. Then continue doing it, making whatever changes you need to. Then when you're ready to merge your branch, you're going to need to git pull. Make sure you always pull. Make that merge commit, and then we push the merge commit from local to remote. OK, just a side addendum is that what we just did is we had this merge commit. So Tony had his branch. He made a merge commit here, and then he pushed that merge commit to remote main. This will work fine for our projects, but in any industry setting, when you're actually doing software engineering, you would not be doing this. Because typically when we're in an industry setting, we as a regular entry-level software engineer or intern or whatever don't have access to push anything, even a merge commit, to remote main. Because everyone's working on remote main, all of the developers. If we mess something up on there, it's kind of screwed. So what we would typically do in an industry setting is instead of merging and then pushing the merge commit, we make sure that the remote branch has whatever commits that we want it to have. And then we do git pull origin main to make sure that any new changes from main on remote are pulled into our branch. This is to avoid any unnecessary merge conflicts and things. And then make sure that our branch matches whatever changes were made to remote main. And then we do something called a pull request. So this is going online on like GitHub or whatever software that your company uses. And then it's basically a request to your manager or whoever's in charge, whoever has admin permissions on the repo, to merge this branch of changes that I made, in this case weblab Tinder, into remote main. So it's just an online interface where the manager or other software developers can review your code, check it off, OK, that looks good. And then GitHub will automatically merge it for you. So that's how you would do things in an industry setting. And then we will go back to our local git pull, and then we have everything that is on remote. And then, of course, we want to delete our branches. OK, this is a reference for the workflow that we would do if we were in an industry setting. And now we're just going to briefly do a little addendum on a tool that you will use probably many, many, many times throughout your projects, and that is git stash. It's also useful for the workshops. So let's say that Tony is working on his code, and this is in like dotted lines because he hasn't committed this yet. He's just making some code, some changes in his VS code. He hasn't staged or committed anything. He's just got his changes in his VS code. But let's say he wants to git checkout main. Let's say he wants to go back and see, oh, how did we do that in the main branch again? What did I change there? Something like that. He wants to just check it. And then, oh, he got cock-blocked again. What happened? So it says your local changes to the following files will be overwritten by checkout, and then whatever this file is. Please commit your changes or stash them. Oh, what does that mean? Before you switch branches. So basically what Git realizes is that if he checked out to main, then that moves the head pointer to main. What does that mean? Well, the head pointer basically just says, where in my Git object graph is my current VS Code state of the files representing? So if he checked out to main, that would change all of the files in his VS Code to match whatever this last commit on main is, which means that all of the changes that he made and didn't commit would just be wiped out forever. Git knows that you probably don't want to wipe out changes if you were working on stuff, and so that's why it gave him that error message. So what he can do instead is git stash, and that takes all of these changes that he used to have that he didn't commit or anything, that he had just in his editor, and it's almost like it sticks it off in a box to the side. And it's just like, OK, I'm going to hold on to it. And now head represents whatever the last committed version was. And now he can git check out main. He can check out whatever other branches he wants. He can change up whatever's going on in his VS Code, look at this, look at that, anything he wants to do. He can even pull from remote if he realizes there was stuff in remote that he needed that he didn't have. And then once he's ready to bring those changes back and keep working on it, he does git stash pop. And that will take the changes that he was making before out of the little box and re-implement them straight into his VS Code editor. So he can just pick up right where he was working before. So git stash, then doing whatever you want, and then git stash pop allows you to hold on to changes that you're working on but haven't committed or anything yet. What about the orange circle? Between the second yellow circle and the orange circle. So it's basically like, tell me if this answers your question. So basically what happens is if he pulls, so he had his head here, then he stashed all of his current working changes, and now he's pulling from origin main. So basically this just takes whatever changes, whatever updates were made, and applies them to the version of the code that he has currently. That might cause some merge conflicts, depending on if this is different than this. But he can just resolve those merge conflicts, figure it out. And then git stash pop will just take those changes that he had made before and apply them to this version of the code. Yeah. Got it. OK. Workflow is good. Yes, question? We wouldn't call it merge conflicts per se, because it's not merging, but it's a good question. So if you pop off of the stash, and that makes some changes that are different from what was in the orange circle, then it would overwrite the changes that were in the orange circle. Because it's as if we had the orange circle, and then we just went in and edited things. Cool. So basic workflow, git stash, do whatever you want, git stash pop. OK, I am, for the sake of time, not going to go over the recap. But a couple recommendations. There's this website called Learn Git Branching, which is a kind of gamified Git practice website that is pretty nice. And we also have, there's a Git cheat sheet that you can look at if you want to reference commands. Also, just in general, I literally just Stack Overflow. I have to look up the commands for anything anytime I do it, but you just how to do this on Git, and then it'll just tell you. OK. Last bit of feedback for today, if you could take 1 minute to fill this out, and then we'll move into final announcements.